All right, welcome everyone. This is a talk on data structures and data representation in App Inventor. And sort of my goal with this talk is that hopefully you'll be able to take some of the content we cover here and use it in your hackathon applications to improve how you represent data and manipulate data as part of your apps. Now, App Inventor has two key data structures that it provides for you. The first is the list, and the second is the dictionary. So lists are very straightforward, and you're probably all familiar with sort of the concept of a list. But you have a list, and a list has any number of items in it. It can be empty if you have 0 items, or you can have 1 or more items inside of it. And the list is constructed by either using the make a list block or the create an empty list block. And you can put any type of item inside of a list. You could put numbers, you can put Boolean values like true and false, you can put references to components. So if you wanted to store a button in a list, you can do that. You can also programmatically add to lists. So for example, there's this add items to list block. And just for the sake of demonstration, you could do something like this, where now we've had this list name is the element 0, true, and the save button, and say we wanted to put another list inside of that. We could do something like this as an example. So lists, importantly, are just a sequence of items. The first element is element 1, the second element is element 2, and so forth. The list can contain any type of thing in App Inventor, and you can both add and remove items from them. So I made a little app just to kind of show what that would look like. So this is just like a little, you can imagine it could be like the prototype for a like a contact list, for example. So by default, my list is empty, and that's represented by this list view at the top here. There's no data in my system, but I can add data to it by clicking this add button. And it gives me this little form here where I can put the given name of somebody and the surname. So I could say John Smith is the person I'm going to add, and I can press save, and now John Smith appears in my list. And then maybe I want to add someone else. So maybe John Smith has a sister, Jane Smith, so I can add Jane Smith to the system. And because this is a list, I would be able to manipulate it. So I have an edit feature as well. So like I could select John Smith, and maybe he prefers to go by Jack instead of John. So I can hit save, and now it's Jack Smith. So that's kind of how you would be able to do it. And then of course, as I mentioned, you can remove elements. So I can select Jack, and I can click remove. And now he's out of the system, and it's just Jane there. So let me kind of show you how this works under the hood. So what I've done is I've represented my app using virtual screens. So rather than having 2 screens where I'm switching back and forth, I've built my app such that I have 2 vertical arrangements. Let me zoom in a little bit. So the first arrangement is person list view, which is the first screen I kind of showed you where I have the list of people. And then the second is person form, which was the screen where I edit or add people to the system. And this one's a very straightforward setup where you just have a couple text boxes and a button to save. Now, on the edit screen, which is where a lot of the basic work is done, because until you add somebody into the system, there's nothing to really do. So let's start there. So this is the click handler for the save button. Now there's a little bit of logic here that we'll get to in a moment, but for just for the sake of the discussion, know that the first time through the system, this if statement is true. So this global viewing is the person I'm currently viewing. So if there's nobody in the system, I have nobody to view. And that's really kind of important for kicking it off. And so when I save and I'm viewing nobody, I need to create a new person to represent the person I'm editing. So I have a method called createPerson, which takes these two text boxes. Actually, let me just, for the sake of readability, rename these. Okay. So there's a createPerson function. And for the moment, let's just pretend that the person object's opaque, but we'll dig into how it's constructed later. I now add an item to the list called people, and people is just initialized at the beginning to an empty list, which makes sense, right? So our list starts off empty, and we add a person to it. And then I'm using TinyDB to actually persist that information across runs of the application. So as I'm making edits, I actually can keep my data stored in TinyDB, and so every time I change something, it loads it back out. So my app is always reflecting what's on disk. So I have next person ID, which is essentially just a counter, and it starts at 0 and goes up every time we add somebody. And I store people, which is my list of people. And so I could actually, for example, if I go to my initialize and say do it, at the moment, because my system is empty again, the result of reading the data out is the empty list, which is indicated by these square brackets with no information between them. If I add somebody to the system, so let me put John Smith back in, and I do it again, you see there's a lot more information here. And you'll see there's a little bit, it's not just the fact that there's something in the list, which there is, because now there's this other set of curly braces that you can see, but we see information about the individual in terms of the structure. So we see that there's a given name and it's John, there's an ID, which is 5, and there's a surname, which is Smith. So the given name and the surname sort of make up the information that we had in our form. And then there's also this ID, which you don't see in the form, but is used for keeping track of identifying John Smith. And so if you've ever worked with a database, for example, you'll know that in pretty much every database system, you have this concept of a primary key. And the purpose of the primary key is to uniquely identify every item in the database. And so this ID here works as a primary key. So if we wanted to build a more sophisticated application, we could do that, but that's kind of outside the scope of this talk. And so when I save, I update all this information, and then I reset my viewing state to be an empty person again. I do a little bit of maintenance here. I hide the keyboard because otherwise the keyboard's always visible, and it's not particularly useful when you're not on the editing screen. And then I have this method to show the person list. But let's go inside of this createPerson method to see exactly what goes on when we create our person. So to create a person, I defined a procedure, which you can do with the procedures drawer. And there are two types of procedures. You have a procedure that does something and does not return a value, or produce some other information. And then you have a procedure that does have a result of some kind. And in the case of this createPerson method, it's a procedure that creates a person and then returns the person object back to the rest of the system. And to represent a person, I'm using a dictionary. So a dictionary is, I mean, if you've ever used like a physical paper dictionary, right? A physical dictionary maps a word to some definition of that word. In computer parlance, we usually talk about keys and values. So a dictionary will have a key, which is kind of, you know, it could be a single word like ID here, but in reality, you can provide any string. I've chosen to sort of stick with kind of common naming conventions you'd see in other programming languages. So for example, I have given underscore name, but App Inventor is perfectly happy if you were to say given space name. Or, you know, you could do, you know, given thinky face name. You know, it's not particular about what you use as the key, other than it either needs to be a string or an integer or, you know, some numeric value, or it can be a component so that you can kind of hang information off of components. And then the value is sort of what's the definition of this? And if you've used, you know, variables like we do here, you can think of sort of the set of variables as a dictionary that maps the name of the variable, the key, to the value of the variable. And it's the same thing here. So you can imagine that sort of ID is sort of a property of the dictionary. It's not quite true, but that property then maps this value, or this variable maps that value. And so we have these three fields: ID, given name, and surname, which basically just match up with the data that we saw coming from TinyDB. Now, the difference between dictionaries and lists is that dictionaries are not ordered, right? So when you put 5 elements into a list, they always should come back the exact same order, right? If you put A, B, C, D, E, then when you read them back, you should get A, B, C, D, E. That's not guaranteed with dictionaries, because what dictionaries do is they're always thinking about a mapping of the key to the value. And internally, what a dictionary does in App Inventor is it uses a system called what's called a hash, which is kind of a fancy mathematical mechanism for trying to come up with a unique number for every key, and then it internally uses that number to map very quickly to the value. But that hashing mechanism doesn't always guarantee that things are going to stay in the same order. But the upside is that it makes it very fast. So we'll see, you know, even though ID was the first thing in my dictionary, right? Given name is the first thing that gets read out. ID is second, and then surname is last. So that's just more of an implementation detail. But when you look at the structure of your dictionaries, don't be surprised if you see that things aren't quite in the same order you put them in. But know that it's done to make everything faster inside of your app. So we construct a person and store some information on about that person for the purposes of sort of simulating the primary key system in a database. I increment the next person ID, and then I return the person. Now, you wouldn't actually always have to do this. Like if you weren't particular about needing to keep track of a unique identifier for everybody you add to the system, you could sort of skip some of this, but just for the sake of demonstration, you know, some of you who are maybe building more sophisticated apps might need this type of mechanism. So I just provided that as an example. So that's what we use to create our representations of people. And so next, so we've done all that, and now we show the person list once we've saved our entry. So let's look at what show person list does. It's pretty straightforward. We hide our form and show our new list, or go back to the first page, which was the list page. And then what we need to do is, it's not sufficient to just take our people list and assign it to the elements of the list. So actually, I'm on the right page here. Yeah. So if I were to just, for example, change this to global people, you'll see when my list updates, I get all this I get basically the internal representation of the dictionary, right, where it's got the curly braces and the names of all the fields and stuff. And so you don't want to show that to your user. So what I did here is I wrote this little helper function where basically I create a new list called the name list, and then I iterate over all the people, and then I add to this name list the result of this get string for person, which is just a very simple function that joins the given name to the surname of the person. And I made it a procedure because if you're building a more sophisticated app, you might need to show information about the person in multiple places in the app. So you have this as kind of a helper function that you can use. So no matter where you need to talk about a particular person, you could always render their name at any point in the app. So we go and we basically take the people list and we build a parallel list that is the name of each person, and then we assign that to our list, and then we end up with John Smith. Now, let's say you wanted to have it be a little bit more sophisticated. Maybe you don't want to show first name, last name, but you want to show last name, comma, first name. Well, then all you'd need to do everywhere in your app, you change this function. And so we'll put, comma, and then we can just swap these two. And then if I do this again, now it's Smith, comma, John. So when you're thinking about designing your apps, you can think about what types of abstractions you might want to do in terms of how you lay out your data. And so one way to do that is by having procedures like this so that you can manipulate your objects very easily to change what the representation looks like. And now it's back to John Smith. So. All right. So then the last kind of major piece of this, well, maybe quickly, there's the remove piece is very simple. So let me cover that first. When you remove somebody from the system, it's very straightforward because the elements in the list are parallel to the list of people. You can use the selection index to remove the person from the list. I update the TinyDB so that next time I load the app, it will reflect the fact that I removed somebody. And then I just call show person list again to update the list. Now, granted, there are other ways you could do this that might be a little bit more efficient. Like you could go in and remove the specific element from inside the list of elements and stuff like that. But since I already have this helper function, I just figured I would call that. But like in any system, there are multiple ways to do the exact same thing. So do what you think makes the most sense for you. So let's talk about editing, which is kind of the last major piece of this particular app. So to edit somebody, I created a helper function called showPersonInfo, which is responsible for sort of configuring that form and then showing it. And to show the info for somebody, you just have to get them out of the person list, or the people list rather. And again, following on from the removing, you can use the selection index to get the particular person and show their info. So let's look at that. So there's some, very basic setup here where we remove the list view and then show the form. We set the text for the first name text box to be the given name of the person, or the surname of the person for the last name. And then, as I mentioned at the beginning, there's this viewing thing. And so this is where we get a little bit creative. So the viewing variable either points to one of these person objects, as the case will be if you're editing the information about somebody. And when you're editing, you'll get their given name and their surname back in the system, right? So we can see it populates the first name and last name with the information about the person. But what about adding right? So I was saying adding was a little bit tricky. And what we do for adding essentially is we just pretend nobody exists, right? So we just give an empty object to basically represent a person who hasn't been kind of created yet. And so when it does that, this third argument of the block to get the information from the dictionary comes into play. So when you try to get the value from a dictionary, you give a key and the dictionary. But if that information doesn't exist, then App Inventor returns this third item, which is the empty string. So when I go to add somebody, I give it an empty dictionary. Neither of these keys exist in the empty dictionary because it's empty. And so I end up with empty text boxes. Now I could, provide some other thing here. I could say first and last. And now if I add, it'll be pre-populated with first and last. But that's not particularly interesting because obviously when we're adding somebody new, we don't know what their name's going to be, so we just leave it blank. So knowing that we use an empty dictionary for representing adding a person, that means that when we're viewing somebody, we have actual information about them. And so if I go back to that save method or event handler, now we can see why this comes into play in this if statement. So when we're adding somebody, we have no information about them. So the size of the dictionary is 0. And so we can use that to then create the person as needed. Otherwise, if we're editing somebody, we will have some information about them. And so what we can do is we can just update the existing object. So we set the given name, we set the surname from the first and last name text boxes. And actually, I didn't quite do this right. I need to also store. So now that I've updated the definition of the person, I can then store it back into the database. So let me do that now. And then we reset our state again and go back to the person list. So that's, a very kind of example that will cover all the bases of a lot of the things you probably want to do with dictionaries and lists. It goes through removing stuff, it goes through adding stuff, it goes through setting and manipulating data. Now, for those of you who have been App Inventor users for a while, you know that dictionaries are a pretty new concept in App Inventor. Obviously, they've been around in programming languages for a very long time, and they go by various names, dictionaries or maps. In JavaScript, most people just use the object type. And in terms of maps, there are things like you can have tree maps, which store information in a tree-like structure. You can have hash maps, which is kind of what we use for our dictionary implementation. So they go by a lot of different names. But in App Inventor, prior to, I believe, December, we didn't have dictionaries. What we had were associative lists, and we still have associative lists. So you'll often come across in an older App Inventor apps, something like this. Which is called an associative list. So an associative list is a list, you also see it referred to as a list of lists. And the idea is that you have one outer list, which has as many elements as you like, to represent data about something, right? So thinking back to our John Smith character, we had something that kind of looked like this, where it had a given name, surname, and in fact, if we wanted to make it match what we saw in TinyDB, it looked like this. And so in an associative list or a list of lists, you always have one outer list and then any number of inner lists, and the inner lists are always 2 elements long. And the first element is basically your key from the dictionary, and the second element is the value of that key. And so in our case, we have given name is John, ID is 5, and surname is Smith. And when you see them, they will look like this because they're just nested lists. So you get a square bracket representing the outer list. Then you have your inner list of data for each of those key value pairs. And in App Inventor, we made it so that you can switch between these two representations. So people who are used to using the old representation can continue using the old representation. But if you prefer to use the newer representation, then in the dictionaries blocks, there is a list of pairs to dictionary, which when you use it will then give you the equivalent dictionary, which matches kind of what we saw before. And likewise, if you have a dictionary, you can go the other way and turn it back into a list of lists. If your code is more comfortable calling that. So now this is equivalent to this, right? And in fact, you could do something like this, and they should return true because they're equal. Now, why would you care about one representation or the other? Well, the big thing that dictionaries brings to the table that list of lists doesn't have is that dictionaries, from a computational perspective, are faster for larger data sets. Essentially, the goal of a hash map, which is what our dictionary uses, is to try to make it so that no matter what piece of information you need inside of it, it should be roughly available in the same amount of time, regardless of how much data you have. In the case of the list of lists approach, you have to look at each element in sequence to find the key that you're looking for. And so if you have a lot of data on an object, like if you've got 100 keys, then you might end up having to look at all 100 in order to find out that, oh, the piece of information I was looking for wasn't even in there. So if you have kind of very complicated data structures or very large data structures in terms of the amount of information you're storing inside of them, sometimes the list will be, it'll take longer to do the same type of operation. And so that's why we provided these mechanisms to swap between the two formats, because you can use the dictionary to do a lot of operations in faster or less time. Now, if you've used another programming language, such as C or Java or JavaScript or Python, you may be familiar with the idea of a struct or a class. Now, App Inventor doesn't have really a first order notion of classes for the most part. We have the components, which sort of are object-like, but you can't make your own easily anyway, and certainly not within the context of the blocks language. But you can sort of use a dictionary to represent in what C would be called a struct, which is really just a set of fields and then some values associated with those fields. And that's essentially what we ended up doing here with our person object, right? So this create person function is just setting up a dictionary with a fixed number of fields. And as long as you continue to use it that way, as far as your code is concerned, it's really just like looking up fields on an object. Now, it doesn't buy you some other of the nice kind of features of object-oriented programming languages where you have inheritance and methods and things like that, but it does allow you to do some very sophisticated representations that would have been harder to do in the older system. So we do think that this is a very valuable thing, and we're kind of expecting that many of you might be able to benefit. So like if you're making a game, you can have like your player be a character, and you can store some information about like what level they are and how much damage they've taken and stuff like that. Or you can have I've represented people here. If you wanted to add more information, like a phone number or something like that, you could do that. Some of you have been talking about making sort of having a login system, and if you wanted to store kind of username and password information, you could do that. So there are lots of different ways you could use these to represent data. And obviously, what information you store is really going to be a function of the app that you're building. So identifying the key pieces of information and then sort of building objects around that's really important, right? So as I was saying earlier, if you want to turn this into, say, like a contact app or an address book app, maybe you would want to store some additional information. Like we could extend this and say, there's going to be a address and a phone number. And we can extend our procedure to take those arguments as well. And now we're going to have a little bit more of a sophisticated app that we could build. And I'm not going to go through the whole exercise. I think it's already halfway through. But now you can imagine that I've done this. Okay, what about building the user interface to populate that data, right? So that's kind of like the next step that you could do. So as you're building out your application, think about using something like Dictionaries, and then as you need, be like, oh, I need to store this information, or I need to store that information, you can go through and add additional content to your objects for later use. All right, let's see, what else are we talking about? JSON interoperability. Yes, Salim?
Evan, there is a question on the chat. I can read it to you, or
sure, yeah.
For sign-in and up screens, which of the following is the best? Fire database, CloudDB, TinyDB, lists, or dictionaries?
Well, that's sort of two different pieces, right? So lists and dictionaries are not persisted anywhere. They're more useful for representing the data in memory while your app is running. If you want that data to live beyond your app when it's running, then you want to use any of those other three. Now, it sort of depends on what the goal is. In the case of TinyDB, TinyDB lives on the phone as part of the app's private data storage. And because it's local, you can update it and read from it immediately. And so as soon as, say, if I go to my save procedure, as soon as the store value block is called here, that data is now stored on my phone. Or in this case, I'm using the emulator, but it's essentially the same idea, right? So as soon as this is called, the data is there in the emulator. If I were to go to a different project and come back or restart my computer or do whatever, when it loads in the initialize, it will get that value back. So that's how TinyDB works. And so if you don't need the data to leave the device, like if the information you're storing doesn't have to go to somebody else, TinyDB is really the best way to go. And it's probably the easiest of all the components to understand in terms of how it stores and retrieves data. Now, Firebase DB and CloudDB work very similarly. It's just more of a question of the backend. So for Firebase, the backend is kind of obviously Google's Firebase. For CloudDB, it's a service we run here at MIT. It's based on a platform called Redis, which is a very straightforward system to store keys and values. There are a number of services out there that provide Redis as a sort of component, like Amazon Web Services does. I think Google does as well. You can run your own. And so that's maybe one value of using something like CloudDB, is that you can keep the data stored on something you control. There are, obviously a lot of legal things around that too, with the EU and GDPR and all that type of stuff, which is sort of outside the scope of this, but it's something that you should think about depending on where you live. In the case of TinyDB and CloudDB, in Firebase DB and CloudDB, they work in an asynchronous way. So Actually, let me pull in CloudDB for now. Now, they share a lot of commonalities with TinyDB. They use the same sort of nomenclature. So, for example, in TinyDB1, we have get value, and in CloudDB1, we have get value. Actually, just for the sake of completeness. Yes. All right, that was probably a mistake, but okay. And in Firebase, we have get value. Right, so they all have a get value block, but you'll note that in the case of TinyDB1, it returns something by virtue of having the little plug here. And in cases of CloudDB and Firebase DB, they're just statements. So you just continue to the next thing. And so we said that these services operate asynchronously because in both cases, they have to go out to the web to get some data from the server, and then you don't know how long that's going to take. You know, if you're on a particularly slow internet connection, it could take multiple seconds even. If you have low bandwidth or somewhere where the connectivity is not great. In other cases, it might be on the order of a couple milliseconds. And so when those components get the data back, they fire this event called got value. And the signature is exactly the same. So they hand you back the tag that was read and the value that was read. And then you can process that. And so the value here in these two event handlers is basically the same conceptually as the value that gets returned by virtue of executing this block. So, so you can then take that and then process it. So if you're doing like a login system, then you might want to do some checking there in terms of authentication and stuff like that. And that would be more valuable for if you have data that's being shared between users of your application. And like I said, TinyDB only ever lives locally, so no other user could see your data because you're not actually sending it anywhere. It just stays stored on your phone. So in the end, it sort of ends up being like, what do you want to do in terms of protecting the data? We've done an example where we had like a journaling app, and maybe you want, you're making this journaling app like a diary, and you want to just have a password locally to authenticate into the app, but you don't actually care about sending the password, up to the cloud, right? And so that would be something you would use TinyDB for. But if you wanted it so that you can make a chat room and have multiple people sharing information, then you probably want to have the authentication system be stored in one of these other two databases.
Evan, there's two more questions. If you want to look at the, can you see the chat while you're presenting?
Yeah. I'll read them. Hello from France. Can you confirm that with TinyDB we can store data in the phone? I'm not sure to understand. Yes. So TinyDB stores the data in the phone. It does not send the data anywhere else, so it's completely local. You could, turn off your, put your phone in airplane mode and do whatever, and the data will stay locally, and that's by design. It's not intended to send your data anywhere, whereas CloudDB and Firebase, by virtue of the fact that they use these cloud services, have to send your data to the cloud. But yeah, for TinyDB, it's particularly good if you want to build sort of privacy sensitive apps because everything stays on the device. It doesn't go anywhere. Okay, so I want to I want the information on every single device, but nobody will be able to see them. Only computer can check. Right. So in that case, if you want to have another system where people view the data, you probably want to use Firebase, because we don't really have a way for people outside of App Inventor to view the data inside of CloudDB. But with Firebase, you can use the Firebase console in Google Cloud to view the data inside the database. So yeah, if you're looking to also have the data viewable by something that's not App Inventor, then Firebase is the way to go. If all you're ever considering is doing it inside of App Inventor, then CloudDB This is perfectly reasonable because it's just talked to by other App Inventor apps. Okay, so I just want to talk about, let's see, I've got 3 other topics to cover. How much time do I have? 15 minutes. All right. So the first is JSON interoperability. So JSON, JSON, is a interchange format for Java. It was originally based on JavaScript, so it stands for JavaScript Object Notation, and defines a couple of different types of data elements that you can use, all of which are pretty much available in App Inventor. So it allows for Boolean values like true or false. It allows for numbers, and that can either be like an integer, 13, or a decimal like 3.14. It allows for strings like our text blocks. It allows for lists, and it allows for dictionaries, right? So basically these 5 categories right here. It also technically allows for, in JavaScript, what's called null, but we don't have a concept of null in App Inventor. So we're just going to pretend it doesn't exist. And so to interact with JSON, you can use these 2 blocks from the web component. So there's JSON object encode and JSON text decode. Now for something like a string, encoding is very straightforward. Right. So I can take the string hello world and I can encode it. Oops. And I get the string hello world, but you'll note that there's a second set of double quotes. And that's because in JavaScript or in JSON, a string has to be enclosed in double quotes. And then it's enclosed in these outer double quotes because App Inventor is showing you, hey, this is a string. So when you call this JSON object encode block, it will always give you a string back. If I say plug in true and then do it, I get the string that's true, the text true. If I want to say make a dictionary, do I have somebody in the system? I do. Okay, so I've got John Smith. So let me make use of John Smith. So I'm going to select from global people, the first element, and then I'm going to encode that. So when I encode the dictionary representing John Smith, I get what we saw before, right? I get a curly brace, the string representing the key, the string in this case, it's a string, so the string representing the value. The ID is a number, so I get the string ID for the key and the number 5, and then surname and Smith. And so why is this valuable? Well, there's a couple of reasons. One, if you want to write the data to, say, a file or something like that, then you can actually encode it, write it to a file, and when you read it back in, you can decode it to get the objects back. And internally, that's kind of what TinyDB is doing under the hood. So TinyDB stores this information in a file on your phone. And when you save stuff to it, it automatically turns it into JSON. And when you read it back, it takes it and turns it back into the objects inside of App Inventor. But the other thing it's really valuable for is if you plan to interact with any web APIs that require you to send data in JSON format, you can construct the data you need to send as objects in App Inventor, encode them using this encode block, and then send them using the other methods of the web component, such as the post text block or the put text, depending on what the API wants. But that's really outside the scope, and it really depends on the API you're using. Likewise, if you are interacting with an API and it sends you JSON back, there's this JSON text decode block. And so what we can do is if I plug this back in here and say do it, you'll see I get the list of list representation, right? And so the reason is because this block actually existed well before we added dictionaries, and so it always returned this list of lists approach. So there's two things you can do. So one is you could use that that block I showed you before from the dictionaries drawer, which turns the list of pairs into a dictionary. So that's one option. Or we have an alternative block, JSON text decode with dictionaries, which basically combines the logic of those two into a single block, and it gives you your dictionary back with your information about John Smith. So a lot of web APIs now return JSON data, and so this is a great way if you're talking to a service over the web and it's sending you JSON back, you can actually decode it and use that information inside your app. We've seen lots of examples where people try to parse the JSON themselves in the blocks. I would definitely not recommend doing that because there are a lot of gotchas, particularly around things like Unicode characters. Like if I come in here and I just put some smiley faces in, and check mark. When I encode it, actually I might not do the right thing. Oh, we'll do the right thing. Okay, cool. So it's actually rendering the character. Normally what you do in JSON is you have to put this, you escape Unicode characters and then put their Unicode number. So it's actually rendering it, but that's okay. But the idea is that, you know, there are all sorts of escapes and things that come up. Actually, if I do /n, I should do the right thing. Yeah. So it has to take the /n, and then when you turn it back, it includes the new line, which is what /n represents. So if you weren't expecting this, then you would actually parse your data wrong. But the components know how to do the right thing and handle all the edge cases, which is really important. So, you know, if you end up building an app, like I said, that interacts with services on the web, then these blocks will become really valuable to you and allow you to do all sorts of stuff with them. I guess I talked about designing data structures already. So again, it's going to be really dependent on the type of app you're building. But as I was saying, if you make use of something like dictionaries, adding new fields and things like that becomes very straightforward so that you can extend your app as you are building it out, which is very nice. And sometimes it makes sense to start simple, right? Like I just started with 2 fields that I thought would be useful, and then I can add more as I go along. In particular, if you're working with a team, then that can be a valuable way of collaborating as well. And then lastly, there are different types of relationships. We didn't really show how to represent those here, but you could in fact say for address, let's just make a slight modification here. So let's say you had something like this. You might have address, city, state, and country. And you might want to actually build a representation of that. So you can nest objects like so. And I could say street address is address. I can say city. So what this allows me to do is I can actually represent these more complicated relationships, right? So the fact that an address is not just potentially a text field, but in fact contains its own structure and interpretation, and right. So I'm calling it state, for example, but that's because I'm in the United States. Like in Canada, you'd call it a province. So you might want to think about how you would represent data across, say, geographical boundaries like that. It also might be the case that you might have more than one address, right? So in the database world, we have this idea of one-to-one relationships where maybe you only ever have one piece of information associated with you, say like a social security number in theory, in practice, not so much. You might have multiple addresses that you could be reached at. So like I can be reached at my home address, but I can also be reached at my work address. And you might want to choose one or the other depending on the purpose of reaching me at that address. Same thing with email addresses. So that's a one-to-many, where sort of like I can have many email addresses, but kind of ideally, all those email addresses point back to me. You don't want to email one of my email addresses and end up necessarily getting somebody else to respond. And then there are what are called many-to-many relationships, where you can sort of have like many people live at this address and they might live at many addresses, or I have many, a friend relationship is a many-to-many. Like I have multiple friends and those friends might have multiple friends, including me and including other people I know. And so those are sort of represented as more graph-like structures. And so if you wanted to say do that inside of this system, what we could probably do, just get rid of some of these temporarily. So we might have, say, a friends list, and rather than duplicating the data, you might have like the list of IDs, right? So let's say I had created, Jane Smith again. I might have her as ID 6 and, somebody else's ID 7. And so you could use that ID to look that person up so that you could represent these cyclical relationships. That's one such way of doing it. But that gets pretty advanced. So you may just want to think about when you're starting to get apps that advanced, what are the different ways I could represent this? And so doing it by just storing the ID is one such way. Like I said, you could make a copy of the data, but then you have this issue potentially where the data becomes out of sync because you don't update all the copies. So that's something to think about. But there are multiple ways of doing many-to-many relationships in App Inventor as well. And at some point, potentially, if you're using more sophisticated databases, like I know there's a number of SQL8 extensions. I don't know if there are any that you could use for the competition, or if you're running something on a server, you can do much more sophisticated relationships on the server side. So, Salim, yes.
Just a couple of more questions and comments if you want to look at those.
Sure.
Claudine, can I use pictures?
Mm-hmm. Can I use pictures and sounds as data that I can store and call later? Yes, well, you don't in App Inventor store the pictures and sounds themselves typically. A lot of the components that interact with pictures and sounds, like the sound recorder and the camera, put the file on disk, and then they return to you a path to the file. And so what you would actually do is you would store the path because it's just a string. And then when you use it with, say, the image, let's try this. So just for grins, I'm going to pull all that out. And we will pull all this out. So okay. And the value will be in it. And then I'm going to put the camera. And on my person form, I'll put a button and an image. And just for saying's sake. And what I'll do is in my show person info, we'll just say that we're going to set the image to the value of image. And I think that might be all we need. Oh no, we need to actually be able to take the picture. So on the button, we will have the camera take the picture, and then in the after taking of the picture, we will set not do that. We will set this to the image, and then in our save method, we will either save the image picture or we will update this. And so I'm just basically extending this by one field, and there are further like abstractions I could have applied on top of this because I was making a small example. I didn't at the time think they were going to be necessary, but as you want to extend, you want to think about how you, once you see like something like this where you've repeated this 3 times, think, oh, how could I make it so I don't have to rewrite the same thing over and over and over again? It's always a great way to improve your application and show some sophistication. And I'm not going to try to be sophisticated right now just because we're doing a live demo. That's fine. But now if I come back here, I can add a person. I'll put me in and see, because I don't know if this is set up to take a picture of me. No, okay. So we'll just take a, that's my picture. And then it shows there, and then I save. And then if I click on it again and I edit, it gives me the picture back. Or if I go to John Smith and edit, he has no picture, but we can take a picture. And so save, and now if I show me, the green thing is there. And if I show John, the green thing's over here. So yeah, you could do that with pictures. CloudDB has a mechanism where you can share pictures. They have to be small enough. It limits it to less than 5 megabytes. But if you were to try to put the path to a picture in CloudDB, it will actually send the picture to everyone who's connected. So that's something you can try. But yes, you can use it with pictures, but be aware that what you're really doing is you're passing around the path to the picture, not the actual image itself in memory. So it's a subtle but very important caveat, or distinction rather. Oh, and then yeah, for where do you get JSON object encode and decode? Those are in the web component. So you would have to add a web component to your app. And then you can find them sort of halfway down the list, maybe slightly less. JSON object encode, JSON text decode, and JSON text decode with dictionaries. And again, the difference between these two is the latter one will decode JSON dictionaries as App Inventor dictionaries, and the former will do it using the list of list notation. And so it really just depends on what you're more comfortable using. I prefer dictionaries, so I tend to always use the latter one. But it's up to you what you prefer to do. JSON objects, I believe, is procedure. Well, yeah, in a way, yes, it's a procedure on the web component. It's not something I wrote myself in my app. It's part of the App Inventor code base. So in so much as I helped write that code, it is a method that I wrote, but it's not something I created in the blocks. It's written in Java. It works with Web1, is that right? Yes. Or I mean, I could call Web1 something different. I was lazy and I didn't rename it, but you could say, JSON helper object. And then now in my code, I can do JSON helper object .json text decode. The naming is up to you what you want to call it. And the web component works without a web connection, assuming you're just using it for the decode and encode. Obviously, getting and because some of these methods require being on the internet, like get and post, but these helpers, like the JSON decode and encode, those do not require internet access. It's all done locally. So similarly with some of these others, like the URI work and the XML. We didn't really talk about XML, but XML is a different representation for data, sort of like HTML, if you've seen HTML. And it's probably outside the scope of this talk, but we have a number of documents that talk about XML parsing in App Inventor as well. So if you end up needing to work with XML as part of your app, feel free to reach out on Slack and we can give you some pointers. Any other questions? I know we're slightly over time. So I thank you all for sticking with me in spite of that. I hope this was really valuable and you learned a lot about how to sort of structure data for your App Inventor apps. Hopefully I've given you some good ideas to think about as you continue on in the Appathon for the next couple of days. Feel free to ask questions in Slack if there's nothing that was, if you're working on something that's like, oh, I didn't quite remember how to do this, or why should I do X versus Y, feel free to ask. And all the members of our team are there. We recently asked the judges as well to jump on and help people out if they have time. So you have plenty of resources available to you to help out in terms of understanding how to better structure your data and represent information within your apps. One last question. I have a question for screens. Do you want to go ahead and type that in? Can we delete a screen through blocks? Well, the screens are created at design time, right? So they're created by having this add screen here, and you get the drop downs here, and you can remove a screen by clicking this. You can't ever remove screen one, but if you add multiple screens, you can remove other screens. When they get compiled, when you build the app, they actually get translated into what in Android is called activities. And so they exist in your app as code. Now, when you open and close screens, so if you go to control, there's open another screen, where you can open a screen and you give it the name. So if I had a second screen, I could say open screen 2. And then when you're done processing on that screen, you shouldn't say open screen 1 again. What you're supposed to do instead is you should use this close screen block. And so that takes the current screen and quits it basically and goes back to the previous screen. If you're on screen 1, when you call close screen, it exits the application. So you can also achieve that anywhere if you call close application, although that's not considered good user experience that you just randomly quit the application on people. Let them use the back button or press the home screen button to leave the app. So, but yes, you can open and close screens while running the app by using those 2 blocks. But it doesn't really make sense to be able to delete a screen because the screen is part of a read-only bundle, which is the APK file that gets installed on your phone. So, but you can certainly at runtime open and close screens. So, and then if you go on the community site, there are a bunch of pointers about how to use multiple screens effectively, as well as on our, let's see, reference other screens. So if you go to the reference materials, there's building apps with many screens, and it sort of gives you some information about how to manage multiple screens and open and close screens. And a number of our power users have sort of come up with additional strategies that you can use. So definitely look on the community site for some examples of more sophisticated screen management techniques. I have a screen 0 and a screen 1 I want to delete. So for something like that, you can probably use the project merger tool to rename the screens and do that. So you'll have to export your project, load it into the tool, rename stuff, and then import it back in. There's also, if you really wanted to, we have another server AI2 test that allows you to kind of copy and move stuff around within a screen or between screens. And so you can sort of use that to move the content from one screen to another and then delete the old one. But like I said, you can never delete screen 1. So you just need to be aware of that when you're building your app. We can also talk more about that via Slack. So. Are there any other questions about the data structures and representation stuff, or? Okay, well, I will definitely be available on Slack if you have any other questions, and we will call it here. Thanks everyone for taking the time to attend.
Thank you, Evan. Wonderful job. Bye.